Hey guys, how are you? I've been off the grid. I've been working my what off. Uh, so on the last video, the machine did pretty good. I'm really happy with it. Uh, but there are some things that I can check, I can see, and one of them, some of them I won't be able to see them never because of the setup. But some of them I didn't know I could even do it, and I was able to do it last night. So I'm talking about a spindle load. Spindle load is really important for me, and even on my case, because the motor I got on this machine is smaller, let's say less power than the motor that actually came on the machine. So this is supposed to be around uh, 8 horsepower, somewhere over there, 7.5 I believe, 7.5 or 8, and it came with a 10 horsepower motor. Besides, the machine had a gear uh, gearbox that will actually, will put some uh, gear ratio to it, and if you're doing a big cut at a slow RPM, definitely, uh, that horsepower doesn't matter that much. But on my case, since I'm a belt drive machine, and I'm overdriving, so I'm pretty much taking more power out of the motor to reach that, let's say, horsepower on the tool. I got to be looking at that spindle load, that motor load. And I start watching some videos on Haas. There's not many, but I saw some of them running, and not that needle moving, and it's pretty cool. I can see how much load I got on my spindle when I'm cutting. So you saw I was cutting that piece of material, and I didn't know I was how much load I had, and pretty much, I don't know. You might see it on the videos on some of the takes that I did. There might be my shadow climbing out there, up there, with a ladder on the back, and trying to reach my hand to touch the spindle motor on C-axis back there, and that was not cool. And I did it many times. The motor was not hot at all, but sometimes they're not that hot, and there's also a lot of load in it. Or they don't feel that hot, but there's a lot of load on those, or there's a lot of amperage on those winding on the motor. So last night I said I was just watching videos, and I remembered Haas on the videos. It shows that needle on that gauge, and I had the original control from Haas. So I climb up there, snap it off the controller. It's not even a nice gauge, but it's working. So, and I went to the manual on the Vf3 that I got on the drive, the spindle drive that I got, and it has an analog output. And I didn't know I could use it like that, so I went in the manual and read, and you can assign different, let's say, different readings, or readings that the drive does on the setup, or let's say, like voltage output, current output, power, uh, torque, all of that. You can assign those values to that output, to that analog output, and create some kind of voltage, and that voltage we translate it to, or let's say we move it to a gauge or whatever that can read that value. In this case, it's going to be that gauge. Now that gauge is a 1 milliamp. What I understood when I was testing it is, even if I put a point, I believe it's point 0.8 volt to it, it will max out. It's a 1 milliamp, so it's with a little bitty amount of power, you can max out that gauge. So it was really good that inside that, the settings of that output on the drive, there is there's some gain settings, so I can change the gain on that output and create more or less voltage coming out of that output. Just adjusting the setting. So pretty much I'm gonna put it like this. Let's just say that the gauge is maxing out when I'm not even loaded, when the spindle is not even, it's not even loaded, it's just idling, let's say at 1000 RPM, and the needle is full, and I'm at, let's say, 100% gain. I can just decrease that by, let's say, 50%, put it down to 50, and then it is going to stay on the middle, and so on, if we just keep lowering. So pretty much that's what I did. But I got to the point, and I want you to remember this, I got to the point that even if I put it at 1%, the needle was still reading something just hooked to the drive, even if the drive was disabled. So I end up putting, I end up putting a 15,000 ohm resistor. Let's see. This will help. Okay. So here is our gauge. This is our Haas, original Haas gauge. It's got a positive and a negative pin on it. Very simple. That positive pin, I put this 15,000 ohm resistor on it, you know, in serial connection with it. The ground from that gauge is straight to any of the common on the rails here on the drive, and that over there is my AO output, so analog output, right, on this drive. I don't know if there should be many drives that they got the same setup. I don't know, I will have to look into the other ones, but I believe they do. Most of them, maybe not those cheap ones that I have bought from that I thought I was gonna put here, but anyway. So pretty much, like I said, I got a 15,000 ohm straight to the positive. You can put it on the ground too, it don't matter. It's still gonna decrease the amount of power going to that gauge. So you see that gauge right now is idling 0 right there. So I'm gonna take it out of here just for you to see, and I'm gonna just put it, let me see, hopefully you see that. See that? So pretty much I'm putting it, I can see what you're seeing. Okay, come on. So I'm just putting it straight to the output, and if I put it straight to the output here, I still get some reading. So it's really sensitive gauge, right? So I just put that 15,000 over there. That's what I had. I had 100. Wait. Come on. So I had 100,000s and a 15. I would say you can probably go wide with a 5,000 or a 2 or a 3. And what happened is, pretty much that needle is gonna start showing something. As long as you don't show anything, this is my case. This drive maybe have some how to say, parasite electricity going through it or whatever. You can even see I'm showing something over there on my feedback. I mean on my reference voltage. So that's maybe why it's showing that over there. Anyway, so I put that 15 over there. I set up my output, analog output, on my, let's say, reference. I set it to 1, and here, wait, here on the manual to 1, right there. See if it's focused. Here to 1 is output current right there. If I put it to 1, so pretty much we are outputting out of the analog output we assign the value of output current going to the motor, pretty much like this amp meter. That's what we're doing over there. We assigning that value to that output, pretty much. And then on our gain, I put it to 200%. 200% because I got a 15,000 ohm resistor in it, so that would drain some of the power going to the gauge, so you actually have to increase that. But this can be increased to 1000% or minus 1000%. That's the setup on it. So I can go all the way to 1000% or minus. I don't know what that means, but that is the way you can do it. So I got it at 200% because of the resistor. It drains some of the power, so the signal going to the gauge, and it's working. Now let me turn the spindle on. Turn the spindle on. I got it set at 4,000 last night, 4,000 RPM, so it's almost mid-range. I can set it up to 5. Let's set it up to 5. 5. 1, 2, 3, 5. Set it up to 5. That's 5. Escape this. So we are 125 hertz? Yes, hertz. 125 hertz out of 240, I believe. And we got some value here on the gauge. So let's say we idling at 25%, and we have 7.5, 10.3 amps out of one leg. So this supposed to be anywhere from 19 to 22 amp motor on each leg. We are at 7, so we are 7 amp. So let's say we are 7. We're supposed to be almost at what, 40%, which that's a lot of amperage. But this is a 220 volt motor, so maybe the amperage it doubles on a 220 volt motor than a 440 or I don't know 60 3-phase. So anyway, that's what I got over there. It's idling around 25%. Now that percentage can be changed by changing the percentage on the drive, the output that comes out of here. But I'm gonna show you how it reacts when I unplug it. So what I'm doing pretty much is disabling the drive here, stopping. All right, I'm gonna turn it on again. I want you to see how it goes, how it ramps up and then it falls down again. And then I'm gonna unplug it, or turn it off. So ramps down and then holds down. So you're gonna see that it ramps down, it's holding on AC, like braking the motor, and then it's gonna kind of free spin for a little bit and then hold it on DC voltage. That's the way I got it set up, because I want my orientation to come in after the motor is actually stopped. It's in no inertia, no movement at all. I don't want to hit that spindle orientation deal with the motor turning. So that's why I have two kind of ways to stop the motor. So one is just you're gonna see it right there, holding, releasing, hold it again. Yeah. So there you go, guys. Haas original spindle low gauge with the retrofit drive. We are putting out of the analog output. Uh, then what I gotta do is, let's just say on turning on, like this, pretty much this. Say if you see those numbers, I'm gonna turn it on, like ramp it up. So it ramp almost to 24 amp, or actually to 24 amp. I'm trying to do everything here. 22 amps. So 22 amps is if I know. Now I already set that drive for a 7.5 horsepower or 5.5 kilowatt motor and all that. So the drive already knows the characteristics of that motor. So that's pretty much what it's trying to output only. It's not trying to turn on a 20 horsepower motor like it was made for. It's only trying to work with a 8 or 7 horsepower motor. That's why it kind of outputs that only and doesn't push the motor that much. So what I'm gonna do, and I'll show you right now, and I'm gonna do it on the fly because I already had it in mind, but I want to do it in front of you. Let's say we are only picking out around, when we turn on and we are maxing out pretty much on amperage on turning on, which that's not, on my experience, that's not enough, because on full amperage load and ramping up are two different animals. Pretty much you normally gonna see 3, 4, 5 times the amperage load on ramping up on a motor. Let's just say if you got a 10 amp motor, you're gonna see 50 amp on ramping up load on your motor, because it's you know, it's trying to do it. It's trying to get up there pretty quick, so you are gonna see a lot. But for me, on my situation, this being a retrofit and me not knowing everything that motor is gonna be able to do and all the cuts and all that, what I'm gonna do is I'm gonna go ahead and come to my setup here on that output, and I'm gonna go to my percentage, let's say, and I'm gonna turn this percentage, let me turn it up to another 50%. Save that, exit out of there. Yeah, so you see that now I'm ramping. When I'm ramping up, I'm hitting 100%, right? Yeah. So what I'm trying to accomplish here is, I want to make sure if I'm hitting my supposedly amperage limit on the motor on ramping up, I just want to try to be at that max when I'm cutting. Let's see, when I'm milling, that's the max that I want to see. I mean, for now, nothing is gonna happen to the gauge. Worst case scenario, I just come here and I start, let's just say I start milling 1 inch depth per cut, 50,000 step over, 7,500 RPM at 200 inches a minute, and which is an okay cut for this machine. Not for the brother, but for this one, it's fine, no problem. And I see that it's just staying over there around 150%. That's too much. We can put more load in it. So what I'll do is I will come back here, I will change that setting from 250 to 200, and then I will start showing, let's say, 100%, and I will just leave it like that, and I will get used to it depending on how much load. And I'm actually gonna climb up there anyway with a thermometer or whatever, and kind of check my temperature on that motor, looking at my amp meter here and comparing in between the two, in between the real time amp meter on that leg, or either one of the 3 legs of the motor, to whatever is actually showing on this gauge. And once I'm getting used to those two and I'm happy with that, then I will leave the setting alone, and I'm gonna be able to have a spindle load gauge showing all the time in front of the machine, which something that I really need, because I was climbing here like I don't know how many times. I was looking like a monkey climbing up there, trying to put my hand inside Z-axis, trying to get away from Z-axis coming up and all that. So I'm gonna get rid of that. I'm gonna move that gauge. I believe I'm gonna mount it. I don't know if it's gonna look bad or not. I believe I'm gonna mount it here. So these two wires that I got coming out of here, these cables, you know, the power and the Ethernet cable, I'm gonna move it out of there and just put my gauge mounted on this boot or whatever, and that way I'm always looking at it. So I get these wires pulled out of there. There's got to be a hole. There's a hole back there, but that one gets dirty really good. So I'm probably just gonna drill a hole to get this. I can just drill a hole in the bottom. Put a gap on the bottom. Yeah, I'm gonna put a gap on the bottom here. Get the wires that way, and I'm gonna mount it over there so we can always be watching that needle on our spindle load. Okay, guys. So I'm gonna stop here, and I'm gonna post this one now, and I'll post the next one when I'm done with it. And kind of the wiring. The wire is gonna be real simple. It's only two wires coming here, straight over there. I'm gonna put some of those. I always forget the name. These things, whatever you call this thing is, EMI or MIE or whatever, to get, you know, parasite current messing with that wire. Trying to put a double shield wire in it. I believe I have the original wire for that gauge somewhere when I took the machine apart. If I didn't use it on the retrofit, it's got to be somewhere. So yeah, I'm gonna mount it there, put a gap on the bottom, let them wires hang from the bottom, put that clamp, hold that clamp here on this plastic here. Then the gauge is gonna be up here. Yeah, it's gonna look good. And then we'll be looking at that. Okay, I'm gonna stop here. I'll see you in the next one. Remember details like the amount of ohms that I use, kind of the settings. Remember to look for your analog output and use your original Haas gauge if it works. If not, just order you one. I already looked for some of them. They're on eBay for like $15, and it's the same kind of setup. All right, stopping here. See you in the next one.